65 million years in the past, a colossal asteroid, comparable in size to a mountain, collided with the Gulf of Mexico, hurtling at a speed exceeding 60,000 units. This impact unleashed an explosion with a force surpassing 100 trillion tons of TNT, forming a crater spanning 200 kilometers. This incident triggered a global catastrophe, resulting in an 80% extinction of Earth's life forms. While such occurrences are infrequent, larger asteroids have impacted Earth in the past, emphasizing the absence of an assured safety. In his final book, Stephen Hawking emphasized the vulnerability, stating that an asteroid collision represents an uncontrollable threat. The most recent major collision transpired approximately 65 million years ago, and the inevitability of a future event is not a work of science fiction, but a certainty dictated by laws of physics and probability. In 2012, astronomers identified an asteroid with a 1 in 3,000 probability of colliding with Earth within the next 40 years. In 2013, this asteroid, named Duende, was scheduled to have a close encounter with Earth. In February of that year, Duende passed at a distance of just 28,000 kilometers above the Earth's surface. However, the unusual twist occurred when, merely 16 hours prior, an undetected asteroid struck Earth over Chelyabinsk, Russia. A 20-meter wide asteroid exploded only 20 kilometers above ground earlier that morning. In the moment preceding its explosion, it would have appeared larger than the Sun. This event, unbeknownst to the public, unleashed a force 30 times more potent than the Hiroshima nuclear bomb. Despite anticipating an asteroid's approach that day, the prediction proved inaccurate as we encountered a different celestial body. Earth is destined to experience asteroid impacts, as stated by Stephen Hawking. This undeniable reality encompasses encounters with asteroids of varying sizes, occurring potentially within one's lifetime or extending over millions of years. To avoid the fate of the dinosaurs, it's crucial to understand the potential damage caused by different size asteroids. Consider a relatively small asteroid, comparable to the size of a car, which collides with Earth approximately once a year. If such an event occurred at this moment, it would likely manifest as a bright flash in the sky, without significant consequences, as the asteroid would burn up in the atmosphere. Asteroids of this size impact Earth every decade or so, and in the rare event of one descending above you, it might even be visible burning up in the atmosphere. Larger fragments could potentially reach the ground, producing a loud boom akin to city traffic, approximately 2 minutes after entry. Although our atmosphere is generally adept at handling such occurrences, the real focus lies in exploring more impactful scenarios. Allow me to illustrate the genuine threats we face. Now, let's explore the scenario of colossal asteroid colliding with Earth. I'm currently situated atop the largest granite monolith in all of Australia, measuring approximately 1,000 meters in diameter. If this were an asteroid hurtling toward our planet, genuine concerns would arise. An impact of this magnitude is anticipated to occur roughly every 6 million years. Upon entering the atmosphere, the asteroid would carry an energy equivalent to 750,000 megatons of TNT. Approximately 50 kilometers above the ground, the asteroid would fragment into several smaller rocks, each striking the Earth and causing the instantaneous vaporization and melting of the tons of material. This cataclysmic event would give rise to a crater measuring 16 kilometers in width and 700 meters in depth. Local observers in the vicinity would witness a fireball hundreds of times larger than the Sun, accompanied by ground tremors akin to an earthquake, registering an 8 magnitude on the Richter scale. Massive rock fragments, comparable in size to skyscrapers, would be ejected onto the surrounding area. Finally, 30 seconds post-impact, an air blast would ensue, a wave of high-pressure air traveling at speeds exceeding 3,000 kilometers per second. It's crucial to acknowledge that this level of devastation arises from an asteroid of just one size. Moreover, It's worth noting that an asteroid responsible for the extinction of dinosaurs was over 10 times larger. Recognizing these potential threats, safeguarding ourselves become imperative. Lastly, let's consider asteroids larger than 1 kilometer, often referred to as planet killers. The likelihood of one of these colossal asteroids colliding with Earth stands at 1/50,000 every 100 years. Should such an impact occur, the consequences would be dire. A colossal impact crater spanning hundreds of kilometers would materialize, leading to the decimation of multiple countries in the surrounding region and the potential for global devastation, mirroring the fate of the dinosaurs. The fear of such event has long been ingrained in human consciousness. In 2004, scientists raised concern about an asteroid named Apophis, suggesting a 2.7 chance of impacting Earth in 2029. The public was informed that if a collision were to happen, it would yield a force more potent than hundreds of nuclear bombs, instilling widespread fear. Advances in data and observational capabilities have since allowed us to confidently predict that on April 13, 2029, Apophis will pass just 30,000 kilometers above Earth, with no risk of impact for at least the next century. However, the presence of thousands of similar asteroids along with many larger ones prompts the question, are we truly secure from these potential threats? The fundamental question arises, what if we discover an asteroid heading for Earth and we are certain of impending collision? In such a scenario, scientists debate three primary strategies. First, the option of diverting the asteroid by applying force to kick it out of the Earth's path, essentially using impact to alter its trajectory and protect our planet. The second approach involves a more speculative concept, where the gravity tractor could be employed to pull the asteroid away from its collision course. This method entails positioning a spacecraft just above the asteroid's surface, leveraging gravitational attraction to effect a change in its trajectory. The third strategy involves a more drastic measure, the nuclear option. While it may seem like a last resort tactic, some argue it could be most effective means of safeguarding Earth by detonating a larger nuclear explosive near the asteroid surface. The goal is to break it into smaller pieces, diverting them away from Earth. However, this method poses a potential risk, as it could generate numerous smaller asteroids that might still pose a threat upon colliding with Earth. The proactive pursuit of solutions is evident with ongoing testing of these methods. NASA's DART mission, Double Asteroid Redirection Test, exemplifies this, as it involves sending a spacecraft designed to impact an asteroid to assess the viability of this strategy. The mission achieved success on September 26, 2022, successfully impacting the asteroid and altering Dimorphos's orbit by 33 minutes. While seemingly minor, this alteration could, in theory, be sufficient to redirect an asteroid away from collision path with Earth, provided intervention occurs in a timely manner. Among the asteroids currently under observation, none pose a threat of colliding with Earth within the next 100 years. While this provides a sense of reassurance, it's important to recognize the possibility of an undetected asteroid lurking in the cosmic shadows. Human resilience comes into play in this context. Approximately 800,000 years ago, it is believed that a kilometer-sized asteroid, akin to a granite monolith mentioned earlier, impacted Earth. This event resulted in the dispersal of debris across 10% of the Earth's surface, marking the most substantial impact during the existence of humans. Remarkably, humanity not only endured but survived through that period. This historical precedent prompts the question, if we could withstand such a significant impact in the past, what's to say we cannot do so again in the future? If you like this video, click the next one shown on the screen. I'm sure you'll like it. Thanks for watching.